Way 78 continues our discussion of kinetics and equilibrium, and it deals with the heat of reaction, represented by this symbol, delta H. The important thing to note here is that the heat of a reaction, the amount of energy produced or absorbed, can be found by taking the potential energy of the final products and subtracting it from the potential energy of the starting materials or the reactants. And here, PE represents potential energy. So if you're given a potential energy diagram which shows you the reactants and the products, we know that the heat of the reaction is simply found by taking the potential energy of the final value, the products, and subtracting it from the reactants. And that tells you whether heat is being absorbed or released. And the important thing to note is negative delta H values are exothermic and positive delta H values are endothermic, energies being absorbed. And should you ever forget this information, it's at the bottom of table I in your reference table. Okay, let's try some problems. Millions of tons of ammonia are produced each year for use as a fertilizer to increase food production. Most of the hydrogen needed to produce ammonia comes from a methane gas reacting with steam. This reaction, which occurs in a container under controlled conditions, is shown below in unbalanced equation 1. Here's equation 1. The reaction that produces ammonia is represented by balanced equation 2 shown below. A catalyst can be used to increase the rate of reaction. So here's example 2. A potential energy diagram for equation 2 is shown below. Reaction coordinate just simply means the amount of time that proceeds over the reaction, and here's your potential energy. State what is represented by interval A on the potential energy diagram. Now, if you don't remember how to read the potential energy diagram, remember that this tells you the potential energy of the reaction as it proceeds through the entire process. Your starting value represents your potential energy of reactants. Your final value represents your potential energy of products. This represents from the bottom to the peak the activation energy, the energy of the activated complex, and here is the energy of activation. How much energy do we have to give the reactants to reach that peak so it can proceed to products? Now here, what are we doing? Well, you should note that here, this represents the gap between the products and the reactants. So what is represented by interval A? Well, it's merely the heat of the reaction, or you could just simply write delta H. Interval A represents the difference between the potential energy of the products and the potential energy of the reactants. If you forget the exact term heat of reaction, or should you forget delta H? Which expression represents the heat of reaction for a chemical change in terms of potential energy? Remember, the formula for heat of reaction is calculated by taking the PE of the products and subtracting it from the PE of the reactants. So answer choice 2 is correct. So when it comes to way 78, please note that delta H represents your heat of reaction. We find it by taking the potential energy of the products and subtracting it from the reactants. Alternatively, if you're looking at a potential energy diagram, the difference in the potential energy of the products to the reactants represented by this value right here, A, is delta H, or the heat of the reaction. Negative delta H's mean that the reaction is exothermic, and positive delta H's mean that the reaction is endothermic and energy is absorbed. Thank you for watching.